part of lesson 3.1, we will express the force between electrical charges in a mathematical form and make calculations. And the law that enables us to do that is called Coulomb's law. We will discuss Coulomb's law, which describes the relation between force between electric charges. Now, I have a very light plastic ball in here, and I can actually charge it by induction by bringing a charged plastic sheet. I'm trying to see if I can charge the plastic sheet by rubbing it, and you know, when I bring it close to the neutral object, it's going to get charged. Is that right? Now see what happens. There you are. You see what happened? It came and touched the plastic and went away. Now why did it go away? Look what happens when I bring the plastic near. Now this object now has the same charge as the plastic because it came and touched it. That means it obtained charges by conduction. So here I have a negative charge and a negative charge. What happens when a negative charge is brought near a negative charge? Look at that, it goes away. Now Coulomb's law deals with the magnitude of this electric force. Now what is the magnitude of the electric force between two charges when they are separated by a certain distance? You can see here, this is a repulsive force because they are both like charges. On the other hand, if one is positive and the other is negative, the force will be an attractive force. Alright, what does Coulomb's law say? Coulomb's law gives us a quantitative description of the force on one point charge due to another point charge. You must understand, Coulomb's law only deals with interaction between point charges, not extended charges. Now this is the statement of Coulomb's law. The law says the force between 2 point charges varies directly as the product of the 2 charges and inversely as the square of the distance between their centers. How do I represent that? If Q1 and Q2 are the 2 charges separated by a distance r, Coulomb's law gives us a quantitative measure of this force. Now can you write this as a mathematical equation? This force varies directly as the product of the 2 charges, Q1 times Q2, and inversely as the square of this distance. So I can write it as F equal to a constant times Q1, Q2 divided by R squared. There you are. So if a charge Q1 is separated by a distance R from a charge Q2, the force between them is given by F equal to K Q1 Q2 over R squared. And of course this K is a constant. Can you tell me the unit of this K? How do you find the unit? Look at that. I can solve K like this. F R squared divided by Q1 Q2. Therefore the unit of K will be Newton meter squared per Coulomb squared. That's right. And it has a value. I want you to remember this value. The value of K is 9 times 10 to the power of 9. You see, that's a very easy number to remember. Newton meter squared per Coulomb squared. There you are. That is the mathematical statement of Coulomb's law. K can also be expressed in terms of another constant. And this is another important constant in electricity. K equal to 1 over 4 pi epsilon naught. And what does epsilon naught represent? Epsilon naught is called the permittivity of free space. What is the meaning of permittivity? Well, you see, this charge is able to exert a force on this charge because the medium in between permits the electrical influences to pass through. Some medium do it more efficiently than other mediums. So it is this quantity that represents how efficient the medium is in transmitting the electrical forces. So epsilon 0 is called the permittivity of free space. And this is the value of that epsilon naught. 8.84 times 10 to the negative 12 Coulomb squared per Newton per meter squared. So sometimes we will represent this K as it is. What will be the value of that K then? It will be 9 times 10 to the power of 9. Now, some other times we will write this K as 1 over 4 pi epsilon naught, and this is the value of epsilon naught. You must be familiar with both these forms. And that means if you now replace this K by this value, the force between the two charges will be equal to 1 over 4 pi epsilon naught Q1 Q2 over R squared. Now we will be using this form in most of the calculations today, but later on we will look at that. Alright? Now at the moment, remember the value of K as 9 times 10 to the power of 9 Newton meter squared per Coulomb squared. The statement of Coulomb's law only gives you the magnitude of the force between the charges. The direction of the force between the two charges is obtained by knowing the interaction. A negative charge repels a negative charge. That means the direction is that the force is directed away from each other. Whereas a positive charge attracts a negative charge, the direction of the force is directed towards each other. So, when we calculate the force between two charges, we need to find the magnitude by using the Coulomb's law formula, and we also need to find the direction by using this concept. Force is a vector quantity. We need to describe a force by its magnitude and direction. Let's do a problem. 3 point charges are on the x-axis. Q1 equal to negative 6 microcoulomb at x equal to negative 3 meter. Q2 equal to 4 microcoulomb at the origin. And Q3 equal to negative 6 microcoulomb at x equal to 8 meter. Find the force on Q3 due to the other two charges. Well, here is the picture of that. Q1 is negative 6 microcoulomb. Apparently, my PowerPoint did a very nasty thing here for me. Well, you know what happened? I changed over to Office 2007. And apparently it doesn't like what the earlier version did. This is supposed to be microcoulomb. So I'm expecting all the micro mu to appear as m in the presentation. So please take note of that. This is negative 6 microcoulomb. Q2 is 4 microcoulomb. Q3 is negative 6 microcoulomb. Not millicoulomb as it says here. Alright, so watch that. Okay, well apparently those were not affected, but these are affected. Anyway, what do? We will use some notation, so let's explain what that notations are. We will use the notation F31 for the force on Q3 by Q1. Alright, so what does F31 stands for? Force on Q3 by Q1. F32 stands for force on Q3 by Q2. And R23 stands for distance between charges 2 and 3. R13 stands for distance between charges 1 and 3. Alright, let's use that and now find expressions for each of those. What is R13? R13 is the distance between Q1 and Q3, 8 plus 3, 11 meter. R23, distance between Q2 and Q3 is 8 meter. And therefore F31 is K Q1 Q3 over R13 squared. I hope you understand that notation. Force on 3 due to charge 1 equal to K times Q1 Q3 divided by square of the distance between Q1 and Q3. And we know all these values. K is 9 times 10 to the 9. We know the value of Q1. Now, look at this. Q1 is negative 6 microcoulomb. It is 6 times 10 to the negative 6 coulomb. Microcoulomb needs to be converted to coulomb. Why didn't I use the negative sign there? Because our first aim is to obtain the magnitude of the force. We will obtain the direction by entirely different method. So we will ignore the negative sign now. Therefore, K Q1 Q3 over R13 squared is this quantity, and that is 0.0027 Newton I. Now, how did I arrive at this conclusion? I have assigned a direction for it. This is a negative charge. The force on Q3 by Q1 is an attractive force. That means it is directed in the positive x direction. So this is in the positive x direction because it is a repulsive force. Yes? Is it true? Q3 is negative 6 microcoulomb. Okay. Why is this force in the positive x direction? You can see the force on Q3 by Q1, they are both negative charges. It is a repulsive force. So Q1 will repel Q3, which direction? In the positive x direction. So the force on Q3 by Q1 is a positive x force, 0.0027 Newton I. You see, x vectors are represented by using the unit vector I. Y vectors are represented by using the unit vector J. I suppose you know that from physics 1. Alright, so F31 is 0.0027 Newton in the positive x direction. How about F32? Force on Q3 by Q2. Force on a negative charge by a positive charge is an attractive force. Now, using the values of K, Q2 and Q3, and of course the distance between them, we get that force as negative 0.0034 Newton I. How do I know this is a negative x force? Well, I know it because Q3 is a negative charge, Q2 is a positive charge. The force on Q3 by Q2 is an attractive force. Q2 will attract Q3, so it is a negative x force. F32 is negative 0.0034 Newton I. We got now two x forces. We can find the sum of the two forces. The net force therefore is the positive x force minus, well, the two x forces are added. One is positive, the other is negative. That gives you the net force on Q3 is a negative x force. Negative 7 times